Welcome to this class. In this session, we are going to discuss about solving systems of linear equations by Gauss Jordan elimination method. So the first step, we are going to give the steps you need to follow, or the so-called the algorithm. So algorithm. So these are the steps you need to follow. One, write the augmented matrix of the system of linear equations. So if you don't know how to write augmented matrix form of the system of linear equations, please watch the previous videos. Number two, use elementary row operations to write the augmented matrix in row echelon form. Number three, use elementary row operations to rewrite the row echelon form in two above in reduced row echelon form. And then, so if you don't know how to write matrix in row echelon form and reduced echelon form, please watch the previous videos. Number four, write the system of linear equations corresponding to the matrix in a reduced row echelon form Number five, give the solution from the structure given in four above. So let's demonstrate by an appetizer. Appetizer. Solve by Gauss Jordan elimination method. The system So we have 3x1 minus 4x2 equals to 7. And then 4x1 minus 7x2 equals to 6. So this is the problem. So solution, step 1 is to write the augmented system of the matrix of the system. So we have 3 minus 4, 4 minus 7, 7, 6. So this is the augmented form of matrix. So that's step 1. So step 2, now we carry out the operations. The first thing, we carry out operations to reduce the matrix in, or transform the matrix in rational form, and then thereafter reduce rational form. So because these are system involving two equations, so then the row echelon form is in this structure. So we have this staircase. So therefore we have 3 minus 4, and then 4 minus 7, 7, 6. So we say row 1 to be a third row 1, so that we get to 1 here, and then we keep row 2 to be the way is it this step. So this will transform our matrix to 1 minus 4 over 3, 7 over 3, and then we have 4 minus 7, and then we have 6. So that is our first step on row operations. And then we require this element here to be 0, this one here. So we achieve this one by let R1 to row 1 to be row 1, and then row 2 to be row 2 plus minus 4 of row 1. So this will give us this will have 1 minus 4 over 3, and then 7 over 3. So this will be 0, and then minus 7 plus minus 4 times minus 4 over 3, that will give us minus 5 over 3, and then 6 plus minus 4 times 7 over 3 will give us minus 10 over 3. Now we expect to have 1 in this position for this matrix to be in echelon form. So therefore we achieve that one by fixing row 1 to be row 1, and then row 2 to be minus 3 over 5, and then row 2. So that one will give us 1 minus 4 over 3, 7 over 3, 0, 1, and then this will give us 2. So this step, this matrix we have here, this is in row echelon form. So if it was by Gaussian elimination, then we stop here and then we use back substitution. But then for Gauss Gauss-Jordan elimination, we have also to ensure that this position is 0. So we achieve that one by saying this row 1 will be given by row 1 plus 4 over 3, row 2, and then row 2 remains to be row 2. So by doing this, we'll get the first element in row 1 will be, so we have 1, and then this plus 4 over 3 times 1 gives us 0. And then 7 over 3 plus 4 over 3 times 2 gives us 5. And then, of course, we'll have this one 7 over 3 plus 4 over 3 times 2. So you have 7 over 3 plus 8 over 3. So LCM is 3. So 7 plus 8 is 15 over 3, which is 5. So that's why I have your 5. And then this will be 0, 1, and then this one is 2. So this matrix that we have obtained here is in what we call reduced row echelon form, this matrix here. So then from this, we'll say from which we have the system. So remember, this corresponds to x1, this corresponds to x2. So we'll have x1 equals to 5, and then this one, x2 equals to 2. So clearly, the solution is x1 equals to 5 and x2 equals to 2. So those are the solutions to that given problem. So thank you. In the next video, we are also going to do more examples on Gauss-Jordan elimination method.